So we are recording. All right. So gentlemen, so what we're going to do is Profinet push buttons, any questions you have, and then the second half we're going to do IO link RFID key. And we can talk about anything IO link if you like. I have set up here at my house. I have compact starters on IO link, and I also have some monitoring for current monitoring IO link apparatuses. All right, Profinet push buttons. Out there is some marketing for us. Here's a selection guide for the Sirius Act signaling devices. And everything I'm going to show you today, guys, I'll zip it all up and I'll send it all out to you guys so that you have it. But as you can see, here's the part of the Profinet Sirius Act selection guide. And what I'm going to play with today and show you guys is we're going to do the interface module for safety. And then I'm going to have a push button with indicator, an indicator light is what I'll have in my demo, as I showed you earlier. Here's all the accessories. And then again, the second part of this today is that we're going to talk about the RFID key on IO link. Okay, next item. Well, as I'm the application resource center for controls products, of course, I got to read the manual. So this is the manual for the Profinet push buttons. Here are the two styles that we have. Let me zoom out just a little bit. There you go. And everybody okay? If you don't see anything or need me to come back, please don't be rude and interrupt. So what we have here at the top is the non-safety version. You have the interface module, which can be a push button, selector switch, and an indicator. Then you have up to 20 more devices that you can add on to it. Okay? Then down below, and this is what we'll do today, is this guy here, is that we have a safety module, and then you can add on 20 more devices. The difference between the non-safety and the safety that's very glaring is that the safety has more I/O that you can, in the back of it, that you can tie into. And that's what I'll show today, and I'll demonstrate that today. Okay, any questions here?
Hey, Mark, is that I/O safety categorized I/O?
No, that is not. It is standard I/O. The only thing that is safety is the e-stop, period. So on the backside is non-safety inputs, and I'll demonstrate that today with an analog in, with my potentiometer, and then a digital out with an indicator light that we'll use later today. Okay? All right. Now, so like I said, I've got to read the manual. Here is the manual for the safety version that we're going to use today. Notice that it has two sets of terminal blocks. And here's where it talks about one digital output on the backside, 4 digital inputs, and 1 analog input. That is the additional I/O that come in on these terminal blocks. Okay? Also, in addition, is that it does have the capability to bring in 2 separate power supplies, just in case that they want redundant power supplies, FYI. All right? Okay, here is the, and you get it in screw type or spring type terminals. All right? And then here's the non-standard, or the non-safety. Notice there's no I/O for it. It's just strictly that. Now let's talk real quick about this plug. Number 3, exchangeable memory module supplied as a standard. On the safety, it will come with a memory module. Anybody, Bueller, why would you have a memory module in that unit?
Does that hold your safety code or your configuration?
That is correct.
And I don't know who Bueller is. I don't know who Bueller is.
Bueller. Anyone?
Who is that? Who is that?
Talking about Travis Bueller.
A new employee or something? Or? Yeah, doesn't that keep all your configuration, all of your what's the word I'm looking for? Gosh, I can't think of it.
Well, all the safety parameters, the IP address, the
IP address.
Yep, the safety name for it, so that if this module fails, all they do is unplug this memory module, get a new one, put in the memory module, cycle the power, and it's as if the module never failed. There doesn't need to be any communications or download from the PLC to do that. And I've demonstrated that to a couple of customers already. Same with the non-safety. It does have that, but it does not come with one. And that is an accessory. Notice that is an accessory, and there's the part number for it. Okay. Again, everything I'm showing you today, guys, I can email to anybody who wants it, or I plan on emailing it to the list that joined us. So that plug is on the non-safety. You have to sell it to them if they want that functionality. It does not come with it. It is optional. Okay. All right. Now let's talk about the terminal modules. Okay. On the back side is degree of protection. There's a diag light. It's very easy to install. It's just like our terminal blocks, and it has an integrated LED, and also it has a flashing LED for command if you would like. And that's a checkbox. And if I remember, I'll show you where that's at in the software today. Okay. Again, here is all the different colors for the LEDs. We have amber, red, yellow, green, blue, white. Okay. And then here's just the LED module alone. This is the one with the contactor. And I got to remember to go slow. With dual contact. Yes, with contact, plural. Correct. Yep, plural. Uh-oh. Okay. All right. There's the memory module. Scroll down through. Okay, ribbon cable. Well, first off, this integrated aluminum LED, that is solely for the e-stop or for the command module. That's what this is for. The non-safety or safety command module. Here's the ribbon cable. Either spot in a 5-meter length or a 10-meter length.
Hey, Mark, on the e-stop, if you install that LED module, can you also configure the brightness and the light pulse frequency like you can on the others?
Yes.
LED?
In version 15, they gave you that. The version 15 of Portal, that was told that you can do that now. In 14, you cannot. It's on or off. Okay. All right, just here's an overview of the safety module. And here is putting together, and I can demonstrate this if you guys want, but I think it would be more profitable for us if I get into the bits and bytes of stuff. Here's one thing that I do want to bring up with you guys. If you bear with me just for a quick moment, let me make sure I got the right one here. I had all this planned out in my head to run so smoothly. Okay, let's see here. I want to bring up the starter kits. That's not it. Let's see here. That's not it. Oh, there it is. Okay. There is a starter kit for each of this, gentlemen. There is a starter kit for the non-safety and the safety.
Yeah.
And I'm very proud to show that Siemens labels these scissors with Siemens on it. So I've got a tie from Siemens, and now I have scissors from Siemens. So this is pretty cool. I got a tie that when I was at Hanover Fair, and it was specifically made by Siemens. It says on the back. Kind of funny. Anyway, so here's the starter kits. Our product consultants that are around your area, Mike Bjor, Sarah's, the Dan Dodsons, etc. They can help you with these guys. But these are really good kits that gives you the complete ability to wire this all up, demonstrate to your customers. You do not need a PLC. The kit comes with a power supply. Unfortunately, it's a European power supply, so it comes with a little plug to adapt to the US. And you can show them demonstrating how to put them together and how you power them up and show them the diagnostic lights. And that's pretty much about the extent.
I just got one of these for Colmac, and the adapter was not in there.
Oh, great.
We chucked it promptly.
Okay. That may have been the oversight by the factory, but all you need is 24 volts to get it going. Okay, and this starter kit flyer is also on the DRC, and then any of the manuals are on our support website. But again, I'm going to send you guys a zip file of this stuff so that you guys can look at it. And then just here's some of the breakdown again of the part numbers, the LEDs, and so forth and so on. All right. Any questions there on selecting? All right. Quiet as the church mouse. Well, then you know what, gentlemen? We're going to start playing. We're going to get our geek on, and let's start playing with some with the PLC and the push buttons. Everybody knows. Yes, please.
Quick question on TIA portal. Are you able to configure these other devices with basic and professional?
You broke up, Darren. You say it one more time. Am I able to configure?
In basic portal as well as professional?
Yes. Yep. Yes, you can. The big difference of basic and professional is the access to the 1500s and the higher end PLCs. But all the remote I/O, the ET200SP, our push buttons, our soft starts, etc., and all that stuff. If you have the basic, you can still access the Profinet push buttons and then add on the Simicode software or the soft starter software, etc., etc. If you're just going to use the 1200s only.
Thanks.
Not a problem. Okay, for those who haven't played with Portal at all, this is the screen that we call the project view. The kind of the marketing screen that you see everywhere is the Portal view. And that's this guy here. Notice I've got all types of wonderful projects I've been working on. I like the project view because it just, I know it enough now I can move on and work with it. What I'm going to do for time constraints, I'm not going to go build my PLC up. I last night sat down and built up some libraries, and this is some great functionality for your customer. And for the sales guys and for our product consultants, please understand that there's some gleams, if I use a Jimmy Mack word, and Brian, make sure I quote this right, but the nuggets from this is some of the nuggets that I want you to glean from this that you use in front of your customers is the ability to configure quickly and wire quickly and cut down your time in wiring up panels. Because I'm going to show you some pretty cool tools that Portal gives you to reduce commissioning, reduce, as you can see, wiring with the ribbon cable, but reduce commissioning and getting the project up and running. What I'm going to show you today is that I'm going to use a library. And again, I created this PLC last night, downloaded it, got it working perfectly. And again, for our time's sake, we're not here to do PLCs. I'm just going to grab this PLC over here. Whoops, sorry. Let me do quickly. I'm going to create a new project. And I'm just going to call this PBPN IO link. And then I'm going to point it to that folder that I'm going to send you guys. And hit create. And know that Portal's under the hood. If we lift up underneath the hood of the Portal, it's a SQL database is the core or the kernel. It's what runs this. It's SQL database. So right now, I just created a database called PBPN IOLink. And now what I'm going to do is start adding some data tables or devices that's in my project database. Over here on the left-hand side, I have libraries. Now, the reason I want to show this to you guys is that your customer, let's say that he has machine A, B, and C, and those machines have, well, A has 10 push buttons, B has 15, and C only has 3. He can, over here in his libraries, he can set up the hardware config once, save it in his library, and then each time he's doing a project for, depending on which machine, he just drags it over here, drops it into the project, and immediately I already have my PLC already configured and ready to roll. I don't have to go over and, hey, what I/O card's there, and what's this, and what's the part number, what's the firmware, and on and on and on. that my PLC is all ready to roll. Now let's start working on the machine itself and programming it. You can do the same exact thing that I just did there in the libraries with, and if you notice, I'm going to just drag this over here, the next one, and I drop that in. And now I have a little lag here. I have a Profinet, or I have an Ethernet IP SIMA-code that is my baseline for my projects when I'm working with my Allen Bradley Ethernet IP SIMA-code. So I'll delete that out of my project because we're not doing that today. And we'll go back to here and go back to my PLC. Okay, I'm just going to quickly, if you guys want to do a little housekeeping, I'm just going to compile, make sure that everything's good in my project. Everybody's happy. There's my safe, because this is a safety PLC. It wants the password, so I got that done. And everything's happy-go-lucky. Now I'm going to just download real quick, make sure everything's okay. Start search. It's going to go out and find a show all compatible devices. There, it found a compatible device. Found the part number, and I'm going to hit load. And stop all because I am messing with the safety program. Again, Profinet safety interface module, IM module, has to have a Siemens PLC that is safety. So that's why I'm using the safety PLC, and I'm using the Profinet push button safety interface module. All right, let's build our interface module. So I'm going to go to our network view, and now I'm going to go off and I'm going to click on hardware config. Hardware catalog. And now I'm going to go grab that interface module that we're going to use.
Hey, Mark, I've got a quick question. It might be a dumb one. If we have an OEM that's using Compact or Control Logic, is there a Profinet card that you could put in a Compact Logic's rack if they wanted to hang our Profinet pilot devices off of their CPU?
There is, I think Hilshire has one. Don't quote me on that. The latest and greatest.
There's a third party, somebody out there that would allow that gateway to happen. If somebody had Control Logic or a Rockwell platform and they wanted to run our Profinet pilot devices off of it, they'd have to go through that third party card to do it.
That's correct. Yeah. And now, please understand that's about a year or a year and a half ago. The last time I looked at it. They may have some newer and better stuff now, but I just haven't followed up with that. A lot of that third-party interfacing is driven by customers, and I haven't had a lot of customers asking that. So,
I just had it come up with a customer in Albany, is why I'm asking.
Okay. All right, guys. So the hardware config catalog is pretty daunting, and unless you really work with it much, it's kind of hard to find things. I'm going to find what we're looking for two different ways just to show you kind of how to go about doing it. Field devices, HMIs, PE coil, drive starters. So I'm going to go to field devices. Here's our Aussie. And then for push buttons, you want to look for commanding and signal devices. And then interface modules, that's that IM module. And then Profinet. And then here is the non-safety and the safety. And I'll stop there just for a minute so you guys can kind of see that. Okay, so there's the safety and the non-safety. If you weren't sure where it was at, you're trying to figure out, go right up here to the catalog and type in 3SU1400 1, and then hit enter, and it's going to go find that part number. I noticed that it opened up Aussie first, and what I like about Portal is it shows you kind of a picture too, so you say, oh, that's not what I'm looking for. So then you hit the little binoculars, keep going down, just keep scrolling, looking for that certain part number. Now, if you look, it's ran into one of our Aussie push button stations, and I'm kind of going, a little slow, but there. Now it finally found the non-safety interface module, but if I click down one more time, it's going to drop down to the safety one. I did it. There we go. There's the safety one, and again, what I love is it gives you the version. Says, hey, here's the firmware. Notice that there is two different firmwares for these, okay? Last night when I was working with this and walking through it, my unit that I have was at firmware 1.0, but I upgraded the firmware and now I know that I have 1.1. Anything that your customers buy from today on will have 1.1, brand new. Some older stuff may be out there for 1.0. And what the differences of the firmware, I don't know. I'd have to go pull it up and look. Okay, so what I'm going to do is click, drag it out here, and drop it. And now it's in my network. And let's increase this a little bit so you guys can see some stuff. There we go. So now it's in my network. It's not assigned, meaning that it's not assigned to a master or the PLC. So, but what I'm going to do now then is that there's multiple ways of doing this, but I'm just going to click on the little green box and drag over to the other green box and drop her in. Okay? And then what I'm going to do is that I'm going to double click on it, which opens up its own screen to it. Now, you know, I'm kind of a lazy bones. I don't like going over here. So here's your terminal modules, you know, all this good stuff. I kind of don't like doing that. Kind of bums me out. If you have it already wired up, meaning that I have my push button station with the ribbon cables in place, you've got it powered, and it's plugged into the Ethernet to your PLC, guess what you can do with it? Click on the head module, the interface module, right click, and look right here. If anybody can read that, I know it's kind of small, but it says hardware detection, modules from station. Ain't that cool? It just makes I get a geek spasm with it. What that means, guys, if you have 20 push buttons or 20 indicators out there, it's going to populate the entire hardware config file for your customer. Guess what? I just saved him time. Major time in figuring that all out. Okay? Now, I'm going to do it, and I know it's not going to work, but I'm going to do it anyway. Why is it not going to work? Well, the question is that right now, if you look, when I right-clicked on it, it's asking me to assign a Profinet push button device, or assign a device name to it, and to assign a Profibus address to it, or Profisafe, sorry. Okay? So that's first, you need to do that first. Update list. There, it found it. Its IP address is 0.15, and it says it's good. So I hit close, right click again, assign Profisafe address. Here it is here. Click there. And if I'm going too fast, please tell me, guys, okay? Identification. Can I make the connection to the module? Well, that's interesting. Well, I wonder why it won't do that. Well, the key to this is that when it won't do that, if we look at when we assign the device name, I'm showing it one more time. Note the IP address for my unit. It already has an IP address in it, which is 0.15. If I go down here and I go on Ethernet address, look what the project's trying to talk to. It's trying to talk to 0.1. So I'm going to put in 15. Now, if this was brand new out of the box, it would not have an IP address, and I would have taken a different step. I would have assigned it an IP address, then tried to do the steps that I'm doing now, just FYI. So now I'm going to go in here, assign Profinet address. It thinks that it's looking for a .15, and I'm going to say identification. See, it still can't make it. So I've changed the project, but it still doesn't do it. So what I have to do now is that I have to tell the PLC, I'm going to compile, and I'm going to download. I need to tell the interface module that you are talking .15 now, please, with the project. So let's go and search. And we're going to load.
Download the new IP address to be able to detect correctly.
Yep, correct. Okay, now let's see what she does. Hardware detection. Boom. What do you think, guys? it just populated my entire push button, or my Profinet push button modules for me.
And that's basically what you're gonna get in that safety version of the starter kit?
And correct.
Okay.
Correct. And it will work with non-safety also. Sorry guys, that's where I get my geek spasm. That's cool. I don't have to worry about firmware versions. I don't have to worry about if I got the right part number, and I'm sitting here fighting over all this stuff. But notice now, if I want to quickly bring it back to the selection guide, here's a little bit of knowledge. The contactors, okay, with 2 spring contacts.
Mark, we lost your picture.
Did you? Okay, just a minute. Let me get you back there. One moment, please. Sorry about that. Do it again. All right. Oh, you lost me is what you did. Rejoin. Sorry about that. My internet here at my house has not been the best, so I apologize, guys. There we go. Share that screen. Okay. Are you back seeing my screen? Are you guys there? Okay. All right.
Yeah,
All right. Okay. So if you look, here's the command, the 2 spring contacts. Then it has 2 spring contacts with LED, and then it has just the LED. Well, now what you want to look at is, here is, if you look at this graphical representation, the 2 green is your contacts, and then that circle in the middle is an LED. So my first button push is going to be 2 contacts. It could be a selector switch with an LED, or it could be a push button with an LED. Then the next one has no circle in the middle, so that means it's just contacts, and then the one on the far right is just an LED. So that graphical representation can help you. And then also, if you look up here, let me minimize this a little bit right here and pull this up. It says command and command. If you hold there, it tells you exactly what it is. LED module, so forth and so on. All right, any questions there, guys? All right, now here's the next little nugget, that this TI portal, how really good this is. So now I'm like, okay, well, how do I address these inputs and outputs? What do I need to do? So if you go right here and click on that module, and you go to I/O tags, look, here is the I/O addressing already done for you. So I can go here and say this is push button start _1, and go push button start _2, because there's 2 contacts. So there's the 2 contacts, 1, 2, and that's input 59.0 and 59.1. And then there's an output because there's an LED. All right, so then I'm going to call that PB. Oh, I'm going to call that push button 1 LED. And now I have just made the tags for that push button. And guess what? If I go here to PLC tags, show all, there they are there. I'm sorry, that's awesome. There's no mistake of getting your addressing wrong, and you're able to go right to it and work right with it. Now we're going to do the same thing over here. Notice this is just, go ahead.
What was the one you showed me before you had to kind of get the general neighborhood of the address, and you went online with a force watch cable to determine which device was which?
Okay, I'm still going to do that. Let me show you what that means. Here's the kicker. You go here to the safety module. So I'm clicking on the safety module, and I go to I/O tags. Guess what? No tags available. The interface module is not doing that in 15. I'm not sure why it didn't happen. I don't know who to report and ask what's going on. But if I click on the individual modules themselves, you can see that it's doing it. But the interface module is not. It's not giving me the ability to go in and do the tags. And that's on the non-safety also, just FYI. So let me finish here with the modules, and then we can move on. So this is going to be PB underscore 2, or yep, underscore 2.
Great.
And let me click here. Sorry, I'm getting ahead of myself. Yeah, there we go. So I'm gonna call
Did
that
you already use?
stop,
Oh.
and I'm gonna call that 2 for push button 2. And then I'll do the same thing here, or sorry, yeah. 1, there we go. And PB underscore stop underscore 2. Okay, then I'm gonna go here, LED 2, and now I've done all my tag base. And I could have done that for all 20 of those apparatuses if I had more. Okay? So these 3 are already been done. They're finished. Now let's address this guy. This is where we get into the bits and the bytes, guys. Everybody might fall asleep on me, but kind of stay awake because there's more to come. That's going to be pretty cool. If you look here, here's the addressing for it, the F module. It starts out at 50. So if you look here, my address for that one was 59.0. That's a bit. And that's that command module at 59.0. And then its output is at 48. That's there, 48.0. Now, here's the kind of, some of your programmers might say, a little bit of a downside to it. But it takes up a byte. Each of these modules take up a byte, which is 8 bits, right? Because here's 59. And that's 59.0 through 59.7. And all this does is it's only going to use 3 of those bytes. So there's a lot left over. But yet, that's what they use for. Maybe there's something coming down the road that our programming buddies in Germany know that they're given. The reason why they did that is for a byte, is there might be some other stuff coming down the road. All right? So if I go up here to this module here, it starts at address 50. And then here's the analog, 51 and 52. I have an analog input. And then here's my safety, 53 through 58. And then here's my outputs. So Jeff, your talk that I told you about is that what I'm going to do so that I can kind of play with and make sure I get the right bits and bytes is I'm going to go now, I'm going to download this of all the stuff that I already have connected to it. Notice that I've got some PLC tags that are different now from the online, offline. And then I'm going to say load. Now, one key item here, guys, is that because I'm changing hardware, I change the hardware, it will stop the PLC every time. Okay? I hit finish, and that's good. Now what I'm going to do is that I'm going to go down here just to verify that I've got all my inputs and outputs, is I'm going to go grab and do a watch table. Add new, and I'm going to call it rename, and I'm going to call it eStop. And then what I'm going to do is I'm going to start, if you remember, I had it start at 50, and it goes all the way down to 58. So that means what I'm going to do next is I'm going to go I50.0, and then I'm just going to drag this bad boy down. Okay? And if you notice, it kind of keeps it, and then here it turns yellow when I start getting into the I/O points that are safety. All right? And then I'm just going to go online with them. And now I've got all these true and so forth. Now, gentlemen, I'm kind of doing this my way. I like doing it this way. It's a preference. If you have a customer that's eager to kind of look at the manual, then I'm going to switch over to the manual real quick. And I'm going to scroll down. And in the manual, it does give you the addressing for an eStop. So let me just quickly get there. Bear with me for a moment. Should have had that roll down the page. We're almost there, bud, guys. Okay, so here's what with a process image for the fail-safe. And here he comes in and says, I have 1 byte, so slot 0, I have one byte. Here's where you would reference your customer name to understand. Here's the 6 digital ins, 2 digital outs. Here's the 1 analog in. Okay? So forth and so on. All right? This is what I would give them to show them that. But now I'm going to go back to the PLC, and my e-stop is pushed. So if you notice, just as if you'll keep your eye right here, I don't think I can zoom in, sorry. But if you watch these 2 bits right here, that's 50.0 and 50.1. I'm pushing my e-stop, and they went false. All right, controls 101. Brian Taylor, you can't answer this. Why is, if my e-stop is not pushed, why am I showing true in the PLC?
The contact's normally open?
You're getting close. Anybody else? The question is, on my e-stop, my e-stop is not engaged, meaning it has not been pushed, but yet I'm showing those 2 bits being true. If I push the e-stop, they go false. Why is that the case? In my mind, I'd say I push a button, it's going to go from false to true. Why is it the opposite with e-stops? Is it? Yeah, you faded out, but I think you got it. Is that you want to have normally closed contacts on e-stops because you want them to fail open. Okay? So on e-stops, and if just a little note for Simicode, the stop button, the local stop on Simicode also has to be a normally closed contact because you want it to fail open. You don't want so nobody know that it's not working properly and they go hit the e-stop and it just doesn't do anything. If the contactors fail, then you'll know because the machine will stop even though you're not pushing the e-stop. And so that's what the purpose of that is. So if I look right there and I push that button, there's my e-stop reset. There's my e-stop pushed. Notice 2 contactors. So I'm going to call this e-stop 1. And it's going to get mad at me because I need to download to it, and I'm not going to do that. We'll just leave that alone. Whoops, that's not what we want to do. My apologies. Delete. There we go. And we'll go back here to input 50.0. Okay. So 50.0 and 50.1. So then I'm going to go over here, and I'm going to go offline. That's the reason why it didn't like me doing that, because I was online. So I'm going to call that e-stop _1. And I'm going to call it, and it still doesn't like me doing that, I50.0. So I'm going to go up to the PLC tag, and I'm going to go add new and go e-stop 1 _1. And I'm going to call that bad boy I50.0. And then if I grab this and do that, drop it down, that automatically cycles up the number and it also moves the bit to 50.1. So now if I go back to my watch table and go online, now I know that that's my e-stop and it's been pushed. Okay? Any questions there? Does that help in any shape or form? Do you guys have any other questions with it?
So you addressed the inside the actual module for the e-stop. So what we did before, though, with all the other devices is address what those bits were. Is that correct?
Uh-huh.
Okay, but the actual interface module has to have it separately because of the, was it the addressing with the IP or?
Yep, let me go offline. So here I was able to automatically address there right here per command unit, command module. But with this guy, I'm not able to do it. It just, the software is not showing me tags, how to go about doing it. So my method of doing it is that I go in here, I start with the address that it begins, and I start pulling down and monitoring and seeing as I push the button, like so now we go back online. So there's my e-stop, so forth and so on. Okay. Now, what I also want to do is that I have a push button in here. Let me plug in my analog. So I'm going to go offline, and I'm going to put in my analog that I know that I have. So if we go back here to my command, and let's go offline again. There's my analog input at 51. So in my watch table, I'm going to go here, and sorry. So I'm going to go over here, and I'm going to get rid of this. Delete that. And I'm just going to put in input word 51, and I'm going to call that a decimal. Go here, and then go online. And now let me plug in, I think I'm plugged in, no, not yet. Let me plug in my power supply for my potentiometer.
And Mark, you again, it said that everything else is 24 volt except for the pot has to be 10 volt.
Yes, the potentiometer analog input for that is 0 to 10 volts only.
Will we ever do a potentiometer that's 24 volts? So you can just use the same power you're using on everything else?
Well, it's really not the problem with the 24 volts that we can use. It's the input doing 0 to 10 volts. So I don't see any reason, or I mean, I could ask them and find out. And that's what we do with the product consultants guys, is that we get with them and ask them to help us get that going. We could put that into our, there is about every 6 weeks is a meeting with our counterparts in Germany over products that we want to bring out and work on with and so forth and so on. And I could definitely put that down on the list and say, when can we get this, or if we can get this.
And what are you using for a 10 volt power supply then?
For me, I'm using, bear with me, just a little 24 or 10 volt power supply that I found. It's a 12 volt power supply. I'm using a 12 volt power supply. And then I'm just using that. I'm not sure why it's not working. I may have not wired this up properly. But I'm using the 12 volt power supply. That's something I just plug into the wall. So we have a 12 volt power supply that we could offer our customer for that analog if they want, or they could do a voltage divider on it too. Does that add a little more complexity, or? So we could go that route with it. And there's some reason why it's not showing up right now. My pot's not working properly. I must have done something, bumped it or something last night when I was tearing everything apart. But you can see the values changing. It's just not changing when I rotate the potentiometer. I'm not sure why I had to quickly jump onto a meter.
Hey Mark, this is Troy.
Yes, Troy.
Hey, what I've done in the past, and we built some PLC and logo demos in the past, and we used a resistor with your 24 volt supply, so you don't have a lot of extra hardware included. So you can drop a resistor across the 24 volts and drop that down to your 10 volt range.
What value are you using?
With a 10K pod, I think it was an 11K ohm resistor that I chose, and you'd have to do the calculations, but I know that got me right into I had a pile of resistors and I went through and got me to where I needed to be. But I think I just ordered a whole string of 11K resistors that we used on some trainer demos that we built once upon a time, and that worked really slick because there's no real current going through there. You're just dropping that voltage down for, to get it in the right range.
So you're just building a voltage divider?
Basically, yeah.
Yep. And you got 24 volts coming in, and then you got 2 resistors, and you're tapping off in between, and using that voltage as it gets dropped off across that first resistor.
Yeah, there's a couple.
Seems like kind of a funky way to get there. I mean, it works, I get all of that, but it would seem to me as though we would have a cleaner way to get where we're trying to get. Would you agree?
Yeah, I mean, it'd be nice if they would offer either a 0 to 10 volt
module
version.
of some kind. Yeah.
Yeah, or a 0 to 24 volt version. So, yeah, I agree. Any other
Seems
questions?
kind of hokey.
Yeah, it does.
It works, but
It gets you there. Any other questions, guys? Okay. Well, that was the extent of the Profinet demonstration on push buttons. Is there any questions? Let me go to one other item I failed to mention. Bear with me just for a second.
Mark, you also might iterate, which we found out from Chester Alliance. This is not a iDevice, a shared device. So unlike other Profinet devices, if you need to share those signals with another part of a machine, you got to do your get puts or send and receives versus an iDevice.
Correct. Now, if you look here, I used an external power supply. Notice here, I'm looking at the connection to a potentiometer. This is the block on the back of the safety. Notice that there is a voltage that comes out under UV, and then you put it across your pot. So it does have a 10-volt output under UV.
What page is that in the manual?
That would be page
52, it looks like.
Yeah.
52 or
There it is.
53.
Okay.
Yeah, 52.
Thanks.
So I may try to do that myself on that one. Okay. Here's my emphasis I wanted to put forth with you guys was when you're wiring them with your customers. Find the page that I wanted to show. I want to talk to you is that when we're showing the customer, and let me zoom in a little bit here so you guys can see exactly what I'm talking about. See the dot? When they're wiring, that's for that red stripe in the cable. That's for that red stripe to go in the dot and then coming out.
Yeah.
Right. And notice there's an in and there's an out. They're not bidirectional. It doesn't. You have to put the in coming in from wherever it's coming from, and then go out. And notice that the red dot is on the bottom for out. So what that means, guys, is that little ribbon cable is going to have a gentle twist to it to go into the next unit. Okay? And that's imperative that you do that way. I've had a customer call me about it and says, I've got like 3 working right and the other 5 are not. And so I had him FaceTime me and I watched, and every one of them, he didn't put the twist in that ribbon cable to be able to go from the out down here to the in up here. He didn't put that twist in. He just started shoving cables in. And the first 4 that worked was just sheer luck that he got it right.
If you watch the Carter Williams video on the controls webpage, he does a video and illustrates that in the video as well too. So
Excellent.
if you go to the controls website, you look under Act and Profinet, he's got 2, I think, videos down there. One of them, he shows you how to do the twist to make sure that you get the red stripe in the dot position.
Awesome. Thank you, Mike. All right. Any more questions on the Profinet? Does anybody? I mean, like I said, I'm going to send you guys out I'll send you out the selection tools. I'll send you out the manual so that you have it for your customers. If somebody buys them, they kind of say, "Hey, here's everything." Do you guys have any questions? Do you have any hesitation on going out and selling this stuff?
No, it's a great product.
Okay, so let me throw this out to you. And not everybody understands what I do, and maybe everybody does. So I am an application resource guy for the controls products. And right now there's only 3 of us, John Burns, Jeff Woolfolk, and I. And I'm here to help my product consultants who right now officially I have Mr. Bjorn, I have Brad Hicks, Sarah, Ken McCleary, and Jim Wright. And those are the guys that I help. And I've helped Dan Dodson also down in Texas when Mr. Burns is tied up with some other stuff. And so if you have a customer that's looking at this and wants to use this, I have no problem getting on a webinar and doing this and showing this and walking them through it and answering any questions, resolve any concerns. or if we have the ability to kind of fill up my schedule, I have no problem coming out to your areas and helping doing a SciPec event or a lunch and learn or anything. And when I come, I bring all my own gear, and then I bring the eye candy that I am. So make sure you let me know. I'm eager to resolve all the concerns. I really think that we have the complete tools from conception to bed and helping our customers start using this and saving time and money using TI Portal and the Profinet push buttons. So please, gentlemen, use me, abuse me. If there's not any further questions, then we will switch to a different topic. Is that okay?
Hey, Mark, one quick question. Are there any plans to put a 2-port switch in this thing so you can daisy chain to another station?
Thank you, Troy. Yes. Don't know when. I don't have a timetable. You remember I said earlier with Mike asking about 24 volts. We have that about every 6 to 8 weeks. We have that conference call with the mothership, and we talk with Jürgen and the product managers and so forth with Germany. And we have a list of things that we are asking for, and they give us statuses of, yes, we can do this. Oh, we're already got it in design. And that is in design. I don't know how much further I have. Our last meeting was canceled due to everybody was on vacation in August in Germany. So I think that's coming up here in the next few weeks, and I will be glad to drop you a note, let you know the status. It is on the list, and I know that it is in one of the priorities to get that coming.
Oh, cool. That's cool. That's very cool. Good question.
Thanks, Troy. All right.
Good question, Troy.
We'll click off there. We'll click off there. And then we're going to go to this next, gentlemen. Let me drag this down. IO-Link. I'm going to just give a quick overview of IO-Link. And for some reason, it decided to go share a different screen. So let me quickly share a different screen. Sorry about that. The Berger command module has 3 monitors here today, so I have to hurry. There we go. Share the screen. Okay. Let's turn you on. See, that's the other thing, guys. I'm going to have you write that you'll never talk about the Berger Bat Cave, what you see in it. I cracked myself up. Sorry. Okay. Here is just a quick presentation that I did with the IO-Link when we go with customers, just to review what it is. IO-Link is a communication protocol that, as you can see, all manufacturers use it. We have quite a few people out there. Now, I want to emphasize to the salespeople a couple of items real quick, because, when I was a sales guy, Rockwell was my nemesis. If you notice that Rockwell is in here in IO-Link, but towards the end of this little presentation, I want to tell you something about that, them being in IO-Link, that I think is a huge deal. So just bear down for that one and make a couple of notes. Okay, it is not a network. It is a master-to-device communication protocol. It only allows you to have 4 devices per port. It only does 60 feet max, okay? Meaning it doesn't go very far. It's not to be distributed out into the field of your machine and stuff. There's no device addressing like Aussie. You have, address 1, 2, 3, or so forth. It uses 24-volt power supply. And then it is mostly, if you want to think of it this way, it's automating inside your main cabinet. It's reducing wire. So how it communicates, whoops, sorry about that. Mouse clicky.
Hey, Mark, I got to get on the road and head to Eugene, so I'm going to have to bow out of this part of it, so I'll have to circle back with you again on it. My real question with the IO-Link had to do with programming that white key. Darren and I have a customer in Idaho that's looking for unique key combinations for some 2 and 3 position selectors, and I was hoping that we could get to some of that, although I'm not certain that would be a good solution, and that he's probably not going to buy our PLC and put an IO-Link module on it to get there. But
let me pause. What PLC, Mike, with it?
What PLC? That's Darren. I'm not sure. It's Hilux Poly. only is the customer. I don't know what their platform is or not.
Darren, do you know what it
Darren,
is?
answer that.
Yeah, right now they've got some old S5s that they're in an evaluation phase of replacing. So hopefully it'll be ours in the future.
Okay, just FYI, Al Bradley has an IO-Link master, and that's what I was alluding to just a minute ago. And Mike, Darren, you're going to stick around, right?
Absolutely.
Okay, so I do have the white key with me, and I was going to talk about that in just a little bit. Sorry, Mike, I didn't get to it quick enough.
Okay, no, that's no problem. I'm gonna try and join and at least listen. I just won't be able to see the screen because I'm gonna be on the road. So
All right,
I'll check out and then check back in. All right, thanks.
Safe travels. All right, so inside the main cabinet, this is what IO-Link is. It is automating or reducing wiring in the main cabinet. Now, here's an example of that. You guys, if you saw the road show truck, this is a picture of it in there, talking about 80 wires versus 12 wires with starters. It is a direct addressing in that's huge for programmers. It's not some little smoke and mirrors thing for it to talk to it. In the PLC, you have the IO-Link master, and I said here, just a couple screens up, I said that it is a 4 devices or ports per master. Let me make sure that you understand what I mean by that. If the device is an analog measurement, then that one device is going to take up 1 port. Again, let me emphasize, if it is an analog device, meaning measuring current, measuring voltage, it will take up 1 port of the 4 ports that you have on your master. If it is a discrete on and off, then it will be able to drive 4 of those starters. Okay, so if it's a discrete on and off with starters, it'll be able to drive 4 starters. And that has to do with the bits and the bytes of how much it can communicate. Okay, so if we go down here, IO-Link, 1 channel coming out, the card has 4 channels. Down the wire, it comes over, and it can talk to 4 starters. And if we keep wiring this up, we wire this up, that means that with 4 channels, I can talk to 16 starters, turning them on and off, and getting a group fault and a group warning. Okay? And then we have the ET200SP with IO-Link Master to do the same thing. What don't we have an IO-Link Master? Anyone? What form factor do we not have an IO-Link Master in? I'm showing you the remote I/O and I'm showing you the 1200. What's the other one?
1500?
1500. You will not see, and who knows, Germany might make a liar out of me, but I've been told you will not see an IO-Link Master card for a 1500. You will always have to use it in a ET200SP remote I/O rack. Okay? Just FYI. Okay, here's what I wanted to jump to. Guys, here's the key. I want to try to get you some cracks in that wall that we call Rockwell and getting into. This is a crack right here. Okay? They brought out an IO-Link Master. I have one. I have this setup right here. I have a Compact Logix talking to the IO-Link Master via their Slice I/O. But do you know what Rockwell has for IO-Link devices out there? All they have is a pressure sensor and proximity sensors. That's it. They don't have any control devices at all. As of right now, I was at an IO-Link consortium where everybody came together, the Vallis, the Turks, the Siemens, the Rockwells, and everything. And there was 3 Rockwell guys in this room, and they stood and talked to me about Compact Logix and our starters on IO-Link for a good 45 to an hour, just asking questions. Guys, there's the crack in that Rockwell wall that we always run and bang our heads against. They have an IO-Link module out there. Great. Get rid of the emotion and start selling our starters. Start selling compact starters. Start selling our voltage monitors, our current monitors, our temperature monitors. That's all talks IO-Link. And this is where you utilize me. Okay, I'm going to let's say that I have customer widget XYZ. He's Rockwell hardened. You've been banging your head against that wall, trying to get him to change his PLCs. In fact, he got a little teary-eyed when he heard that there was some equipment coming back from Europe Siemens, but they ended up, paying extra money to switch it to Rockwell. And then guess what? He's got this project where he's doing about 15 starters, and he's really got a real panel crunch. And you want to be able to help him with the reduced wiring and make the panel as small as possible. And so what we could do is say, hey, how about if you're using this Slice IO, how about if you use the IO Link card with Rockwell, and then show him what we can talk IO Link. And then you say, how about if I sign up a webinar and get you to talk with Mark Berger, our application resource guy, and he can walk you through bringing in the IO Link IODD file, which is what communicates to the IO Link. It's like a printer driver back in the day to talk to our starters, and he'll demonstrate using Rockwell's PLC how to talk to our controls products. This is a great way to exploit that crack in the wall that we call Rockwell that we bang our heads against sometimes. So please, let's utilize this. If you guys can find some guys they're pretty emotional about it, this is a way for us to come in and show them our starters, our compact starters, our overload relays, our monitor relays, our RFID key, which is what I'm going to focus on today, and be able to break and try to crack open that wall that we're always banging our head against. Okay? So again, let me reemphasize, and I apologize if I sound like a broken record. Gentlemen, we can use this card, and we have videos that shows how to bring in our stuff that John Burns has done. And I'm more than willing, and that's my job, is to do webinars to help your customers and to go on site to help them overcome some of the technical things that they may have with it. All right.
Hey, Mark?
Yep.
Can I ask you a question on this slide?
Which one?
The Rockwell slide.
Yep. Back up. Okay.
So we promote IO-Link as a 60-foot limit inside the control panel, not outside with field devices.
Correct.
So Rockwell with only field devices, are they limited to 60 foot?
Yes. That is an IO Link standard, is 60 feet. Here's the key. What they're doing is they're putting a remote IO, in which we could do the same thing with Ethernet IP, with our ET200 SP, is that we could put this out into a remote box somewhere on the machine, and then have these proc sensors come in, or we can also put a distribution block just outside where it's 60 feet from here to here, right next to the machine, and then bring in all the M8 or M12 connections for these apparatuses, these sensors. We can do the same exact thing. Just note that from this master to those devices is only 60 feet. Okay?
And do they risk any electrical interference running those out in the field?
No, it's pretty stout communication protocol. It's looking for DC signals, and then the analog or the noise that's put on that backbone. What I've seen of it on the oscilloscope and so forth, it's pretty robust. It is not required. If you notice, if my little screen here, the only wiring that they have you use is no special cable. The wire that I use for my demos here is I ordered a 15-foot long sensor cable wire, which had 3 conductors, and that's all you use. There's no braided or any type of grounding or anything like that for the communications, because it's so robust looking for that discrete digital transition and not all the analog noise. It kind of just filters it out for it.
Okay, thanks. I was just looking for chinks.
Yep. The chinks, if you want to go with the chinks, the downside too is that this is not a network. And so a lot of that diagnostics that a network could provide is not there. We do provide some, and I'll show you some of the diagnostics that we can get back. But the chink is the distance. It's only 60 feet. Now, if you want me to bring up one other item with it, is safety. Notice that we don't have anything safety yet on IO-Link, but there is a manufacturer out there that has safety on IO-Link. Anybody want to venture a guess who it is?
Siemens?
No, Siemens does not have safety on IO-Link.
Okay.
It's, you guys are, I don't know about Sirius. Balluff. Balluff is pushing safety on IO-Link. Not to dive too much into this, to the minutia, but what it is that the IO-Link is a group of consortiums of people that have sent out a specification. Balluff is, there's a new specification for IO-Link, an IEEE standard, and Balluff has gone out on the limb to start doing safety. Well, all the rest of us manufacturers have said, well, let's hold off a little bit. Let's make sure this is robust enough. And Balluff has said, oh, I'm going to go for it. And so if you call your the Balluff guy, he's got some safety IO-Link stuff, but it's nothing real pressing. I've interacted with, or I've come in contact with it twice, and right now it's really not that impressive, but they're still pushing a lot of it. So just FYI. Okay, let's jump to what we came here to do. Let me just quickly, here's how we talk to all those 16 starters. There is a ribbon cable that goes in between them. This is a standard starter, a standard 3RT contactor, but the only difference is that in the front of that contactor, there's 3 little pinholes that the IO-Link comm module interacts with. And that's what you got to make sure. And at the end of the 3RT 1024 or 2024 dash, and it's CC0. And that would tell you that it is an IO-Link contactor. It can be used in normal application, or you can put on the comm module on the front, okay, for those contactors. So we're talking 12 wires to talk to 16 starters, okay? All right. So here's just kind of the bits and the bytes. Like I said, that was the reason why analog is 16 bits. So if I have an analog I/O device, I'm going to use up all 16 bits. But because I'm just using a starter that's on and off, that means that I could put here starter 1 with 4 bytes, starter 2 with 4 bytes, starter 3 with 4 bytes, starter 4 with 4 bytes. Okay, what do you get in those 4 bytes? You get zeros ready, meaning this is ready, motor on, that bit right there. General warning, there is something in the warning, could be overload or it could be voltage or loss of phase, and then a general fault, okay? And then on the outputs, you have a 0, and that tells you either command on, clockwise or counterclockwise, and then tells you which direction it is turned on, okay? That's the bits and the bytes of it all. Then the RFID key, that is only for one channel because it has analog data to it, but it's not really analog data. It's just, it takes up the entire packet of data for one channel. And then we have also, here's our monitoring relays, 1.6 to 16 amp, 4.0 to 40 amps, 8.0 to 80 amps. These are great little units, guys, for if any of your customers are trying to get back just some simplistic key performance data and using it with IO-Link, real quick to wire and real quick to get the data out of it, okay? We're going to focus on the RFID key once I finish this little PowerPoint. Again, Rockwell. And then here is for us that monitoring relay, some of the data that you can get because it has an analog. Here's your group errors, and then here's your analog value of what voltage or current, so forth and so on, okay? Now, I'm not going to dive too deep into this, but here's, when we use our Siemens PLC, this data is called, this data here is considered called cyclic data. Cyclic data means that it's coming to the PLC every 50 milliseconds. And it's always cycling and always coming. It's always there. But then we have the ability to get acyclic data. Now, Mark, what do you mean by acyclic data? Well, acyclic data means that an event has to happen. Meaning I have to have an event happen to go get this data from my IO-Link device. So if you notice, if I have this set up in my PLC with an event, in which that event could be a 2 hertz clock, or it could be somebody pushing a button that says, extended data, and it goes off and it will report all this data back to you. This little device we're talking, it's the cost of a overload relay, and look what it can give them. Group error, threshold undershoot violated, phase failure, blocking current. Here's our power min, all this data can come back via that little monitoring relay. It takes a little programming. It's nothing real fast and slick, but it once you get it programmed, it's phenomenal. Now, just FYI, for the programming on our support website, there is a library, like I showed you in the TI portal about how I drag that PLC out, but there is a library for software to go off and create that acyclic event and to populate data blocks in the PLC. And that's one of my webinars that I could do for one of your customers that's looking to bringing in some acyclic data from an IO-Link device. And that's just not for the monitoring relays. That's also for our the current voltage and temperature modules that we have. Okay. All right. Now we're here. What we wanted to talk about is the RFID key. Has anybody played with the RFID key?
Yes.
IO-Link version or non-IO-Link?
Non.
Okay, so non-IO-Link version just closes contacts in the back for you. We are going to talk the IO-Link version, all right? I've got one wired up, and I'm going to show you and demonstrate it in the PLC that we just finished with. Okay, here's some more of these data sets. Key position, authorized level, identification number, codable ID key. Okay, Brian or Darren, this is one for you. This is that number 4, the white key, and we'll talk about that in just a minute. Real quick, I want to advertise something from Mr. Burns. As the Application Resource Center, and as our time is maybe not being used, we kind of go off and find some pet projects. Mr. Burns has found a pet project that is phenomenal. What he has done, and it started with a customer that we met at Automation Summit. The customer was just checking out our stuff. I am hoping that this year's Automation Summit, FYI, it's in Denver this year, everybody. And last year we had what we called open engineering, where all the business units just brought a bunch of equipment and set it up. Motion, PLCs, controls products. John and I set up 2 Simico demos, IO-Link demos, and we just sat there and waited. And customers would come by, and if there was a class they didn't like to attend, they sat down and we just did hands-on and just said, what do you want to learn? And we just walked through and they said, show me this, show me that. Well, this gentleman was kind of opening up his heart to John about some of his headaches. And one of his biggest headaches was his inability to quantify why that machine was down. And I won't go into what machine it was, but the key here is that he was having trouble. The operator pointed at maintenance saying, well, it's his fault because he's not up and running. And maintenance was pointing at the operator saying, well, he's just turning it off and going off on a smoke break. And production was pointing at him that there wasn't enough product upstream. So that kind of gave John a thought, and one crazy day, he went off and has created a key performance indicator using our RFID key. And it is in our new demos. If there is a one panel, comfort panel demo with compact logics and our monitor relays that's all IO-Link. And he's added this to the HMI. But what you've done is that he said, okay, the green RFID key is for my operators. The blue one is for my maintenance, and then the red one's for production. And so each time the key was put in place, it come up on the screen and says, please select time to start. And they selected the time, and to make a long story short, what he ended up doing was exporting and showing in the HMI each time that the customer, the operator or maintenance or production, they classified downtime or uptime, and he was able to quantify that and start figuring out some problems with his production on it. And so it gave you the ability, him to see that the machine wouldn't start unless the operator put in his key. and then he touched, same start production. But if something broke down, then the operator walked up, pulled his key out, and then it comes up on the screen and says why down, and it classified it that maintenance has been called. And then the maintenance guy shows up, he plugs in the key, and it comes up and says working on machine, and then he works on the machine. When he's finished, he pulls it out. It comes up and says machine turned over to production, and then it shows the production guy or the operator come over and put his key in and start it up. And that customer was tickled pink about that. That helped them tremendously to get some key performance indicators on the machine that they are using. So that's demoed. I could be glad to demo it with a customer. But think about that, measuring, if this machine ain't running, the company's not making money. So they want to quantify downtime. Well, upstream, we don't have product coming from upstream. Our maintenance guys, they're so tied up with other products, they didn't have time to get down to this machine. So you're able to start measuring things and improve things so the machine has a lot more uptime than downtime. Let's just move on. I'll move on now let's talk about the RFID key. Let me share that with the screen again now. Bear with me. Any questions, guys? I hope this is fulfilling what you were looking for.
Well, besides the technical aspect, there's also some good ideas.
Yeah. Okay, here's the operator. This is the manual. Again, as the application resource guy, I got to read the manuals. So this is just some of that the bits and the bytes and the wiring. Darren, here's that signal. You remember I talked about that signal of the analog and so forth? Yep. Here it is here. Okay, it's either at 4.8, 38.4, or 230 kilobits per second. It is a DC 24-volt signal, and it's a differential signal. Okay, I hope that kind of helps a little bit for it. All right?
Yeah.
Okay, and it could be wired in different ways. The main wiring that we will do today is this wiring here. But let's get into our RFID key. All right, everybody has kind of seen it. They've kind of worked with it, so forth and so on. But here's the RFID key. There are different colors. Minimize this, slow that out there. Okay. There is group 1 is green. Group 2 is yellow. Group 3 is red. Group 4 is blue. Then there is a white. Now, with that, the white can assume all authorization levels. So, Darren, what this is, and you guys, is the white can be whatever you want it to be. It's the universal key. All right? And what I mean by that is that you can have that white just be green only of that authorization, or you can have that white be yellow only. The key to here is that it gives you the ability, because each of those white ones have a unique, never repeated hexadecimal code that the PLC can read and give whatever authorization it wants to that person. So what I mean by that is that instead of handing out a green one, a yellow one, a red one, and blue, the PLC programmer can hand out white ones, and then he reads the hexadecimal code that comes across, and then he says, okay, here is my operator's sign-in information, BERG, and he's tied to this hexadecimal code with this RFID key. And then that gives him the authorization to stop the machine, start the machine, open up safety gates, et cetera, et cetera. And that's all done in the PLC. The key to the white one is that this gives your customer a flexibility to give whatever authorization that they need and be able to do with that. And it's all done in the PLC.
Okay.
Sorry. All right. Go ahead.
So the RFID will never.
Correct. So you fade it out. Let's say it one more time.
So
Correct.
So they could have picked the one employee. And they would have operator that interface.
That's correct. I lost you, Jared.
You answered it, thank you.
Okay. So again, we reemphasize is that white can give the PLC programmer anything with it. Now let me throw something out there just for an example. Let's say that this is our customer is using WinCC 7 point whatever we're at now, 7.x. Within that, there is a user-defined table for authorization to enter into a SCADA system and so forth. All right, so it gives a username and then a password. Well, for extra security, just like we have on our laptops as Siemens employees, we have our PKI card. This can become a PKI card. And that they'll have somebody that's in charge of the SCADA system. He has a reader. He plugs it in. He sees the hexadecimal code. And then he can go tie it to that user's password and identification, and to be able to get into the systems that they are allowing him to do and open up screens for him if he's production versus if he's just maintenance. So that key is an infinitesimal, all the white ones, there's not another one in the world that has that hexadecimal code to be duplicated. And so you're able to go in and give everybody a key, and then each of that hexadecimal code be able to give them the authorization to each of those units. Does that help?
Absolutely.
Okay. All right. Let's go to our loveliness of PLCs. And I'm just going to do a quick item and go add my my IO-Link stuff. Now, please, for time constraints, because we're moving along here, we've been going for about an hour and 20 minutes. I'm going to try to wrap this up because I know you guys got other things to do. But what I'm going to do now is I'm going to go into, for IO-Link, here's my IO-Link master, CM4 by IO-Link. You click on the card, and then right-click, and see this Start Device tool. Yes, there is a separate software called Port Configuration Tool that's been around a long time. I remember it clear back in the old Step 7 days, 95, 96, doing it with the ET200S motor starters and so forth. This is the Start Device tool. So I'm going to click on that. It's going to ask me, is this what you want to start? Say yes. And now it's going to open up that tool. So this tool is how we configure and communicate with the I/O devices. Now my unit has nothing in it. It just says here's the slot, here's the IO-Link, but I have nothing in it. I can do real quick, because I'm lazy, I'm going to go right here. I have everything wired up properly, and I'm going to go right here and I'm going to say load PG. There's two up arrows. One just says load to PG, and one says load to PG with devices. I always do that. I'm going to click there. It says, now, are you sure you want to do this? I'm going to say, yeah. And now it's going to go out and look and see what I have out in the field wired up. And look what it's found. It's found my compact starter. It's found an IO-Link module that has 8 digital ins. It's called the K20. And it's found my Sirius Act ID card. So then I'm going to say, okay, go for it. It's uploading all the information. And again, emphasize, it's all wired up. I have everything wired up properly. Now I could build this up myself in the program and put the stuff in there and call it good if nothing's wired up. I could have gone into the hardware config over here to the catalogs and picked out the devices and put them in there and then saved it and exited out and waited for it to be wired in to download things. But because I did the wiring first, it's done that. Okay? So it's uploading from each of the devices. I have in my Sirius compact starter IO-Link, I have one reversing, two direct starters, and then it goes reversing starter, then 2 direct starters, and then a reversing starter at the end. And there's 4 of them. And I'll be glad to show those in just a sec. And I apologize for taking a little time to upload it. It's taking a little longer than it did last night. but it will come across. And then, you remember we showed that Rockwell had a little distribution block? Well, I do too. Siemens has a little distribution block called the K20, and it has 8 M8 connections that you can put out in the field. It's IP65. And then we have another smaller one that has 2. And I really like those. I've sold a few of those or got some customers to buy those for out in the field. What they were doing is instead of bringing all of the inductive proc sensors and photo eyes into their cabinet, they just ran a wire out about 20 feet from the cabinet of IO-Link, and then mounted it on the side of the machine, and then all those photo eyes landed there. And so they never had to, if a photo eye went bad or a cable got cut, they never had to go back in and go through the cabinet and unwire everything and pull it through the cord rips. Everything was just landed locally, and their maintenance guys were tickled pink because that sure helped cut down their time on winding all the wiring through and so forth and so on. Okay, it's uploaded everything. So now I'm going to go here to the tree, and then underneath my link, and it lists the different what I have. So on my channel 1, I have my compact starter, I have my IO-Link, which is 8 digital ins, the K20, and then I have my electronic RFID key. Real quick, I'm just going to go through here and show you the ports. Here's the 3 items. I don't have one on my 4th channel. Here's my addressing. So for the PLC addressing, I go show PLC addressing, and then all ports. And you say, okay, we're aligning this? Yes, please. And now I get all my PLCs, and here's my inputs and outputs that I'm going to use for my IO-Link that I could copy and paste into my tag data table. Okay? And then I'm going to go to status. And then I'm going to go to INM, which kind of just gives you the serial number, hardware revision, and then commands, factory reset. Okay? Now I'm going to click on the compact starter. And I have identification. Here's
Hey,
the
Mark?
parameter. Yes, please.
Those were all PIIs and PIQs, right?
Correct. That's your process image.
I thought those were only scanned, when you told it to, not every single cyclic scan. So how is it that Valve expects to do that with safety?
I don't know, but that's the
You gotta
key.
scan a lot for safety.
Right, and the IODD file or the how do I put it? The driver file that you pull in. I'm not sure. I haven't played with it, and I'm not really sure how Valve's doing it. I haven't heard anybody really say it's the cat's meow about it. Now, just FYI, guys, it brings that up. I had a customer that called and asked about they wanted to use something from Valve and on our Siemens PLCs. I'm like, yeah, not a problem. Just get me the IODD file, which is the IO-Link device description file, and I imported it. This one up here. It said options, IODD vendor list, import, and then guess what? I go look over here, and there's my Valve, and there's my Smart Light, and this is what they wanted to import. It's that quick and that easy. So just FYI on stuff. If you have customers, they're like, hey, we really like this. And Siemens doesn't make this type of light. So anyway, okay, here's my reverse starters or my compact starters, 8 to 32, yep, so forth and so on. And notice that all this is already done because I had programmed these previously. These weren't fresh out of the box. If they were fresh out of the box, this would all been blank and say any. But because I know what I have and I'd already programmed them before, it's all there. And then also is the starter available? So let's say that you have a customer that has 8 starters, but they're only going to use 6 right now. They can go in here and put the starter in play and say, no, it's not available yet, and it won't fault. And then when somebody finally wires one in, then he can come back in here, hit yes, download, and you're off to the races. Monitoring, I can go online with my starter and see what's going on. So I'm going to go online. There I am. Everybody's ready. Here's starter 1. Now what I'm going to do is I'm going to go flip my breaker, turn off the MSP, and I got a group error for it. Okay? And if I had a motor running and I could simulate overload, Then over here I could go what direction I'm rotating and then a trip reset. But notice that I could do some troubleshooting via the port configuration tool. I'm going to go off online. Diagnostics the same way. Go online there. This is a huge tool for our customers. Turn that off. And there it is, circuit breaker tripped. And it just came up because I turned it off. Motor overload, cooling time. So our customers can go online with this and get all this diagnostics. And again, you remember I said acyclic or cyclic data. This is your acyclic data, and everything you see here, I can acyclic suck out of my compact starter and show it on my HMI with some programming in the PLC. Everything. This DS4 is DS90. It's a data set, or if you've heard the terminology data record, that's what this is for. And we can suck all this data out of each of the starters and have it shown on our HMI and bring it into the PLC. Just FYI. All right, here's the IO link module. Like I said, it's just a quick little, here's its inputs, and I can invert that input so that if it's a normally open contact, I can make it look like a normally closed, so forth. And it's just a little IO block. Now to the RFID parameters. Here we are here. Okay, I've got incremental switch position, so forth, switch rotation delay. If you just want a little bit of a delay or a debounce. Here's set authorization levels. And then here's that hexadecimal code. And then how many IED keys, etc. And then here's some of the information. And then I'm going to go to monitoring. And I'm going to go online. All right, now I'm online. And now I'm going to put in. So somebody tell me what key did I put in? If I have authorization level number 1, what color key? Anyone? Bueller? Is that the yellow? Green. All right, yellow is 2. Okay, now what I'm going to do here, oops, sorry. Now if you watch again, I'm going to turn the switch. And now I'm in position 1. So key is recognized, the unit is ready, authorization is 1, and the position is 1.
Hey,
so
Mark,
go ahead.
aren't each color key, their programs are not, each have a unique serial number?
They have a unique hexadecimal number.
Okay, which is what we had on the truck a couple years ago, showing that you could identify who activated something on a machine.
Correct.
Okay.
So now the other thing that I did with mine is that on the back of this, let me switch to the PDF so that you guys can see what I'm talking about. Sorry, I may have got the wrong. Find the PDF here. This is the PDF I wanted to bring up. Okay, this is the installation guide. Let me bring this up. Here is the non-IO-Link version on the left-hand side or right-hand side. And here's the iLink version. Notice it has digital outputs on the back side. Okay? Notice here's the L+, CQ, and L-. That's where you wire in the IO-Link. And then over here is L+ and 1M, and that's where you wire in your 24 volts. Okay? Why does it have outputs? Well, guess what? When I put in my key or any key into that, my output Q.4, it gives me 24 volts at this output to say that a key has been entered. And then once I select 1, 2, or 3, or 4, then each of these close contacts. So that means you can have some lighting in your cabinet to say, all right, a key is present, which I have in my demo. I put in a key and a light turns on in my demo. And then once I select that permission, that guy right there closes that contact. And then so on and so forth and on. But I think that's cool. There's some really neat implications of using this here in your control panel. It could be also that output could say, okay, I've plugged it in. Then that means the machine can start up. The hydraulic system can turn on. The machine can get ready. And then once they select the selector of which one to use, then that is where they say, okay, you have access to, maintain the machine, get in and maybe some of the safety protocols that you need to open up because he's got to do maintenance work on it. You can use these outputs to do that also. Okay, so pretty slick. I think that's just some pretty ingenious some ideas there that you're thinking about. Now, like I said, here's the non-IO-Link version of that. Okay, it still has the outputs, but notice that the power cord or the L plus C/Q LI is not here because it's not your IO-Link. All right. Any questions there? All right. Well, gentlemen, I really gnawed on your ear, and you're probably getting a little blood in your ears from me talking so much. Is there any questions that I can answer to help you with? Is there any applications? Please, this is the key to start thinking of being your customer's advocate of where you hear some headaches that they're having and that you have some products that could help get rid of those headaches.
We were going to do this on Profinet, Mark?
Yeah, that's on the list to get going. I have not heard the status. Again, the same exact meeting, the products, it is on the list to be done. I just don't know where it's at on the priority list right now. So yes, we are pushing it here in the United States to do it with a Profinet. We're just waiting to hear what they're going to decide on doing with it. But we have expressed our needs for it, and they've acknowledged it. It's just getting Germany to put it as a high priority. So, gentlemen, if I can conclude, I'm here for your application resource to help you guys maybe answer, resolve concerns with your customers. I mean, we as sales guys, we show them flyers. We talk about this stuff, but this is where the bits and the bytes hit the road, and or the rubber hits the road, and I'm eager to help them and resolve some of your concerns. If you need anything else, please reach out to your product consultants and me too. Our product consultants could probably answer a few questions, and then I can dive into deeper ones. I sure appreciate your time. I'm honored that you guys wanted to listen to me, and I'm excited to help you in any way or shape or fashion.
Thanks, Mark. Thanks for your time, Mark.
Hey, be good, guys. Have a great weekend. Don't work too hard.
Right.
We'll talk to y'all later.
Thanks, Mark.
See you guys.
All right.